Hello, and welcome to the second video in the updated tutorial series on YAGSL. This video will be about programming Swerve. I'm going to start from where we left off in the previous video. Let's click the download button, and we're going to see we have YAGSL config.zip. Let's head to File Explorer or Finder and go to the location of where your YAGSL config file is. This is the file we just downloaded from this website. We need to unzip this file, so I'm going to click open and unzip, and it unzipped it for me. And now we have a folder called Swerve. So let's leave this where it is for now and head over to our VS Code. If you do not already have VS Code with WPILib installed, I will leave a tutorial in the description of this video to do exactly that. So head over to your WPILib icon command palette, click on this, and type in create a new project. It'll be the first one right here. So create a new project. I'm going to select a project type. So this will be template, Java, command robot. Select a new project folder. I'm going to create a whole new project folder. New folder. Let's call this YAGSL tutorial vid. Create. Select folder. For project name, I'll call this YAGSL tutorial vids, and team number is 3481, and make sure to check this enable desktop support. This will be helpful in the future, especially if you're going to run simulations. Click generate project. I will open this with a new window, and I do trust the authors. All right, let's get started. So open up source and deploy. You'll notice there's nothing in here besides the example. We need to put our Swerve file that we had unzipped into this deploy folder. So I'm going to head back to my Finder where I had unzipped the Swerve folder. Let me exit this. I'm temporarily going to move this folder to my desktop. Then I'm going to move back to VS Code, right-click deploy, and then click reveal in Finder or File Explorer, and then I'm going to exit this out. Finally, I'm going to move my Swerve folder into my deploy folder. And if we double-click, my Swerve folder is indeed in the deploy folder. So we have succeeded. Let's go back to Visual Studio Code, and you'll notice that deploy is now filled with Swerve, these two JSON files, and all our module files. So step 1 complete. I almost forgot to do this step. So we're going to go to this funky little icon on the left side, and this is where we're going to download our vendor dependencies for YAGSL specifically, the libraries needed to run YAGSL. Scroll down until you see yet another generic Swerve library, YAGSL. Click this install button, and it is going to auto install all the dependencies required for YAGSL. This is extremely quick and easy. Let's move back to the documents and click on source, Java, and then subsystems. We're going to click on this file, example subsystem. Take a look at it. We are going to copy paste this program. So copy, and then I'm going to paste. We are going to rename this to something a little bit better than example subsystem copy. We're going to change it to Swerve subsystem. Okay, so immediately it's going to be angry at you because you are calling it by the wrong name. So I'm going to double click this and replace example subsystem to Swerve subsystem. And same as this. Now that we've created the Swerve subsystem file, let's head over to the documentation once again and scroll down to the configuring YAGSL portion of the documentation and click on code setup. Scroll down until you see this block of code. We're going to take these first 5 lines and copy paste it into the section where we do the imports. These import statements basically give the program access to external libraries needed for the robot to do its thing. They're all pretty important, so let's copy paste it into the program right here. Let's head back to the documentation and copy paste the next 3 lines of code. Copy, back to Visual Studio Code, and paste it underneath public class Swerve subsystem extends subsystem base. Paste it here, fix this formatting. You're going to notice a bunch of immediate problems, which we are going to fix one by one. First of all, this is missing a semicolon. The function of these 3 lines of code is to set up the robot Swerve drivetrain by first converting a maximum speed value into meters, and it locates the folder that contains the Swerve drive configuration files inside the deployed directory. And then finally, it uses those configuration files and the maximum speed value to construct a Swerve drive object. Here, the problem with this is basically what it's doing is creating a file called Swerve JSON directory, and it uses this JSON to create a Swerve drive called Swerve drive. But you'll notice that this and this are not the same name, so we need to change this to directory. Even after all that, this line is still angry. It's basically like a teenager. So we're going to head back to the documentation, scroll down until you see, follow along the example here, click on this link, or probably open it in a new tab, and it'll bring you to a GitHub filled with YAGSL examples. Now, this is the most updated location you can go to reference. It is updated last 4 days ago, so this is very recent. So make sure you go to this link. Do not go to Google and look up YAGSL GitHub, because probably it's going to lead you to the Bronkbots GitHub, which is not the right place. So make sure you're clicking the link off of the documentation. Click on Drive Base Only 2026, Source Main, Java FRC Robot, Swerve Subsystems, Swerve Drive, and then click on Swerve Subsystem.java. Scroll down until you see this right here. From lines 58 to 66, copy this, and then head back to our VS Code. We're going to paste this in public Swerve Subsystem. These lines wrap the create Swerve drive call in a try block because it can throw an exception, and this makes the code compile. If an error happens while the program runs, the catch block rethrows that error as a runtime exception, which stops the program and prints the original error. And if it doesn't fix the error, it only allows the code to compile and fail loudly if something is wrong. By pasting this, you're fixing this line, but you're also adding 2 more problems to the code. The next thing we're going to diagnose is this max speed. This problem basically stems from the naming scheme difference. This is called max_speed, and this is maximum speed. And also it references a constants class. So I actually don't prefer either of these names. Instead, I'm going to go to my constants file and create a new double, public static final double, and then call it max speed. And this will be equal to this, right? Units.feet to meters 4.5. So equal this. And also I added an extra U. Oops. So now I'm going to rename all these to max speed. And that is one more problem checked off. The last thing we need to do is fix this error right here. So to explain this, I'm going to go to the documentation, and click on Java API. You do not need to follow along with me. This is kind of extra, but just so you understand what's going on here. So I'm going to look up create Swerve drive and select this one right here. So this create Swerve drive is basically creating a Swerve drive from the JSON configuration directory. The parameters is the double max speed, which is the max speed of the robot in meters per second, and it's also used for angular acceleration in Swerve controller of the robot. The second parameter is initial pose, pose2d. Initial pose is basically where the robot thinks it's starting. So let's click on pose2d here and go to constructor summary and then look at this portion. Oops, this portion. To fix the error here, we need to set up a pose2d initial pose in this format. Double X, double Y, and rotation 2D is based off of the field coordinate system, which I have a picture of right here. Take a look at it. This is not the same as WPIlib making the X direction positive and to the left. This is like a standard coordinate system with the positive rotation being counterclockwise. So we need to set up an X and Y coordinate and a rotation value for the initial pose of the robot. Before I start fixing this, I want to point out that I made a mistake. We can actually go ahead and delete this line because we did the same exact thing in the constants file, so we no longer need this line. I'm going to go ahead and start typing out the pose 2D. We have created the coordinate 1, 4 with the rotation value 0. One more thing, we need to import meters. I do not know why this is not already there, but we're going back to the documentation, go to the same, I'm in robot container, I should be in Swerve subsystem, copy paste this line 7, head back to VS Code and paste it at the bottom of the imports. Now this error is gone and everything is fixed. With that, we are done with Swerve subsystem, and we will now move on to coding our robot container. So let's open up robotcontainer.java and begin by creating a new Swerve subsystem called DriveBase. Before we create or call any commands, we're going to use Swerve input stream. So let's head over to the documentation and the GitHub examples, and let's go to robotcontainer.java. Scroll down until you see this section right here. We're going to copy this, go back to VS Code, and paste it right here. This code basically sets up a Swerve input stream for controlling a robot Swerve drive using inputs from a gamepad. The left joystick controls the robot's movements, such as forward, backward, left, right, and the Y and X axes are inverted for intuitive control. The right joystick controls the robot's rotation, which is the angular velocity. A deadband is a small range around the center of a joystick where the input is just ignored. It prevents tiny, unintentional movements caused by joystick drift from making the robot move. Finally, the control is set to be alliance relative, which makes sure that the robot movement aligns with the field orientation. Unsurprisingly, copy-pasting this in came with its fair share of errors. We're going to fix this one first. At the top here, you'll notice that we are creating a command Xbox controller object called mDriverController, and that is the name that we want to use here. So let's copy-paste this and paste it in here. Paste it here. Paste it here. And that gets rid of one of the errors. We're going to deal with this one next. Hover over this and click Quick Fix, and then click Create Constant in Operator Constants. It'll create a constant in the constants.java file. Do not know why it's setting it to a string, but this should be a double. And this will be 0.05. Finally, let's fix this. The method getSwerveDrive is undefined for the type Swerve subsystem. So what we're going to do is go into the quick fix and click create method. Now this creates a method in Swerve subsystem.java. Scroll down and we see here, this, I don't know what this means, but we can just type in return Swerve drive. Oops, there. Let's head to the documentation one more time. Now, I was about to say that I feel a little bit bad for copy-pasting so much code from the example, but the example exists for a reason. There's no shame for referencing an example. Use it as much as you need. The more important thing is that you understand the essential parts of the code so that you can troubleshoot later on. I'm going to grab these 3 lines of code and paste it into VS Code right here. Nope, I don't like that. These three lines basically clone the angular velocity input stream and then converts it into a field relative input stream.
Hello, post-editing correction. Both direct angle and angular are field relative by default. Swerve input stream, it by default is going to be field relative. What direct angle actually does is it makes sure that the heading is going to be controlled with a stick instead of being it based on the angular velocity.
Now the problem here is a similar problem we had earlier. Driver Xbox is not what we call the gamepad. We call it M driver controller. So we're going to copy this and paste it where it says these. Oh, I don't like that. There we go. This basically gets the right stick to know where it's turning, aka the heading. Now that we have both velocity and angle, I'm going to start creating commands. So I'm going to be typing it out and explaining it as I go. Basically, this command allows the robot to move in field-oriented mode, where the movement is relative to the field's orientation, using a custom directional angle for control, which is what we set up earlier, this drive direct angle. I'm going to create a second command and then fix this issue after. This command controls the robot's movement in field-oriented mode by adjusting the angular velocity, aka the speed of the rotation. Now to fix this problem, let's hover over this. I'm not even sure how to fix this. So quick fix. Okay, so create method. We're going to create this method in Swerve subsystem. Down here. This seems unhelpful. Actually, this is completely, this is not correct. Okay, so what we're gonna do is make this a public void. Drive field oriented is correct, and then we set this as chassis speed. And grab the velocity. And this is unnecessary. Oh. Yeah, I'm gonna delete this. And type swerve drive drive field oriented, and this should be the velocity. What is wrong here? What? Oh, is this supposed to be chassis speeds? My bad. Okay, so this is gonna be that, and then quick fix, and then import it, because we had not imported it earlier. That's what I had thought the problem was, but it was just me spelling stuff wrong. Basically, drive field oriented is a method that takes a chassis speed object, which defines the robot's velocity in terms of forward, sideways, and rotational speed, and then it passes that velocity to swerve drive, which then moves the robot in field oriented. I'm gonna do one more thing. I'm gonna create a public command called drive field oriented, and then supplier chassis speeds, and then velocity. Curly brace, put this here, and then say return run. This should be this, and then lambda and one more thing, this needs to be imported. Basically, the drive field oriented supply chassis speed velocity method creates a command that drives the robot in a field oriented mode using the chassis speed velocity. All right, so the last thing we need to do is basically call all of this and set it to default. So we are going to put this right here. And we are done. I'm going to quickly summarize what we did in this video because this one was a long one. Swerve subsystem handles the robot's movement using a Swerve drive system, initializing Swerve drive using configuration files. It sets up basic drive commands, and it provides methods for field-oriented driving, which is down here. The robot container class basically configures the robot subsystem's commands, controls. It includes like a bunch of initialization stuff of Swerve subsystem and the controller of command Xbox controller M driver controller. And we use those controller inputs to move the robot around, get some values from it, such as the angular velocity, direct angle, and we use these values to control the robot. It also sets up some basic drive commands and provides methods for field-oriented driving. So that about wraps up this video, and I'll see you in the next one. Happy swerving!